In this video, we will continue practicing the law of sines and the law of cosines. Remember, we will use the law of sines if we are either given angle, side, angle, angle, side, or heaven forbid, we are given side, side, angle. Now, I said heaven forbid because this is the ambiguous case. It's a special case where sometimes there's no solution, sometimes there are two triangles. So that takes a little bit of extra work. We will use the law of cosines whenever we have side, 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 or side, angle, side. So, looking at number 46, I see that we have two sides and an angle. That means it will either be side, side, angle, the ambiguous case, or it will be side, angle, side. At a glance, I can tell which one it is because if the angle matches one of the sides, it's going to be side, side, angle. That's just a little shortcut I've picked up. So this is going to be side, side, angle. It's the ambiguous case, so you really got to watch out because it can make, it's possible that there can be no solution, or there could be one triangle, or there could be two triangles. We're going to have to do some work to figure it out. But here's how you start. You take your one angle that you have and put it on the lower left. So the first triangle I draw is going to look like this. Okay, now I call this the rope because this is the part that makes it ambiguous, meaning I'm not sure how many triangles I'm really going to have. So I draw it as a dotted line. So I can think of it as being flexible, like a rope. Now this side over here on the left is more like a tree, like a leaning tree. It's not going to change. But this is angle A. So this is my 55. And across from angle A must be side A, so that means this is 5. Okay, now the tree, take the other side that you're given and make that the tree, the leaning tree. So this is going to be 8, and so since that was side B, then that means angle B must be right here. All right, and angle C must be here. Now the first thing I have to do is figure out whether or not I can make a triangle at all out of this, because sometimes you can't. Sometimes the rope is too short to reach the ground. So what you want to do is you want to figure out how high off the ground is this point. All right, what is the height of the triangle? And we have to make sure that the rope is long enough to reach. So if this is the height, then it turns out that, look, if I were to do the sine of 55, that would be opposite over hypotenuse, right? So that would be h over 8. Multiplying both sides by 8, I get 8 sine 55 is equal to the height. So let's figure out what that is. 8 sine 55. Oh my goodness, guys, look what's happening. So this is, 6.553. So 6.553. That's the height. All right, so I'm just going to shorten that to 6.6 for now. So the height is 6.6, but the rope is only 5. Guess what that means, guys? The rope is never going to reach the ground. It's too short. All right, the rope is only 5 long, but the height is 6. In order to make a triangle at all, the rope needs to be longer than the height. So I'm just going to stop there and say no solution. All right, because there are no triangles that can be formed with this information. Aw shucks, we're switching it up. Now this time I see that we have all three sides given. So we are given side, side, side information. That means we are going to use the law of cosines. All right, and the law of cosines says this. The first thing I can do is basically I write down the Pythagorean Theorem. So I can write c squared is equal to a squared plus b squared. That's how the law of cosine starts off, just like the Pythagorean Theorem. But then it's minus 2ab cosine of angle C. All right, the cosine matches the whatever side is over here by itself. So I have side C over here, so cosine of angle C. All right, so that is the law of cosines. So now I'm just going to substitute in everything that I've got. So I've got 12 squared is equal to 7 squared plus 6 squared minus 2 times 7 times 6 times the cosine of angle C. Okay, so I need to solve this for angle C. If I subtract 7 squared and 6 squared from both sides, I'm not even going to turn them into 49 and 36. I'm just going to leave them squared. So I'll have 12 squared minus 7 squared minus 6 squared. All right, now I've subtracted these. All right, pretend these are gone. I still need to get cosine C by itself. So next I would divide by negative 2 and 7 and 6. So next I would go like this. I would divide by negative 2 times 7 times 6. Okay, so that would give me cosine C. But what I really want is not the cosine of C. I want angle C itself. So what I really need to do is do the inverse cosine of all of this. So feeling lazy, so I'm just going to copy this real quick. Okay, so if I do the inverse cosine of all of this, then that should equal the measure of angle C. All right? So obviously, I'm looking for all three angles. So I'm going to have to find the measure of angle A, the measure of angle B, and what I'm finding right now is the measure of angle C. All right, so this is about to be my answer box, y'all. Okay, so let's go ahead and get this in the calculator. And I'm just going to put this whole thing in my calculator all at once. Wait, I almost forgot the inverse cosine part. So inverse cosine, and then I've got my 12 squared minus 7 squared minus 6 squared over negative 2. Make sure you use this little small negative sign at the bottom of the calculator. Times 7 times 6. All right, so the measure of angle C is 134.618. All right, so I'm going to do the exact same thing again to find one of the other two angles. Let's say if I want to find the measure of angle B. If I want to find the measure of angle B, then I need to, instead of starting with side C, I'm going to start with side B. So this will be B squared equals. And of course, that's going to leave A squared and C squared. So then that's going to be minus 2AC And then here comes the cosine of angle B. Okay, so B squared. So I've got 6 squared is equal to 7 squared plus 12 squared minus 2 times 7 times 12 cosine B. If I were to subtract the 7 squared and the 12 squared from both sides, that would give me 6 squared minus 7 squared minus 12 squared. Then I would have to divide by negative 2, 7, 12. So divided by negative 2 times 7 times 12. Okay, so that would leave the cosine of B by itself. All right, but I don't want the cosine of B. I want the measure of angle B itself. So what I really need to do is I need to do the inverse cosine of all of this. And the inverse cosine will give me the measure of angle B. All right, so this is what needs to go in the old calculator. So I will do the inverse cosine of, let's see, 6 squared minus 7 squared minus 12 squared. I said 12 squared, but somehow I wrote 11. All right, and then I've got negative 2 times 7 times 12. Okay, so the measure of angle B is 20.849. All right, of course, now that I have 2 out of 3 angles, to find the third angle, I will simply subtract from 180. So if I just do 180 minus 20.849 minus 134.618, that leaves 24.533. All right, so that is it for problem number 47. All right, problem number 48, I see I have 2 sides and an angle. So that means it's either going to be side, angle, side, or it's going to be the dreaded side, side, angle, the ambiguous case that takes more work. At a glance, I can tell which one it's going to be. If it's going to be side, side, angle, then the one angle will match one of the sides. In this case, I have angle C, but I don't have side C. So that means that this is not going to be side, side, angle. It is going to be side, angle, side. And that tells me to use the law of cosines. Okay, side, angle, side, we always use the law of cosines. So let's go ahead and just draw a picture so we have something to look at. Okay, actually, you know what? I'm not going to draw a picture. When I'm doing the law of cosines, I don't really need a picture. Okay, so let's write down all of the things I need. I need the measure of angle A. I need the measure of angle B. And I need the length of side C. So this is my answer box that I'm getting ready. Okay. Let's find the length of side C first. It doesn't really matter. I could have picked any of these, but I just choose to go after side C. And really, the only reason why I'm biased is because I enjoy writing down the Pythagorean theorem first. So if I start with side C, then it goes c squared is equal to a squared plus b squared, all right, which is the Pythagorean theorem if this were a right triangle. But then because it's not a right triangle, we go minus 2ab cosine of angle C. So we have everything except for side C. So we will have c squared is equal to 15 squared plus 18 squared minus 2 times 15 times 18 cosine of 67. If I want to find the measure, the length of side C, I need to take the square root of both sides. So I'm just going to take the square root of this, and I'm going to take the square root of all this. And that will give me side C. Okay, so I need to do the square root of 15 squared plus 18 squared minus 2, and I'm just going to say times 15 times 18 cosine 67. Okay, 18.385. Got to round up. Okay, 1 down, 2 to go. Since I started at the bottom, I might as well just work my way up. So now I'm going to find the measure of angle B. Since I'm looking for the measure of angle B, then the next thing I'm going to put is side B. I'm going to start with side B. So B squared is equal to a squared plus c squared minus 2ac cosine of angle B. All right, the angle B matches the side B. So let's fill in what I know. So I've got 18 squared is equal to 15 squared, okay, plus, now, I now know side C. So I'm going to have to use that. So it's going to be 18.385 squared minus 2 times 15. I'm going to need more space. Times 18.385 cosine of angle B. So I need to solve all this for angle B. So I'm going to start by subtracting 15 squared and 18.385 squared from both sides. So that's going to give me 18 squared minus 15 squared minus 18.385 squared. Next, I need to divide both sides by negative 2 times 15 times 18.385. So I'm dividing by negative 2 times 15 times 18.385. Okay, so that is going to leave me with cosine of B. But I don't want cosine of B, I want the measure of angle B. So if I to find the measure of angle B, I need to do the inverse cosine of all of this. So if I do the inverse cosine of all of this, then that is going to equal the measure of angle B. So here I go, inverse cosine of 18 squared minus 15 squared minus 18.385 squared over negative 2 times 15 times 18.385. So that is 64.320. And that just leaves the measure of angle A. I do not need to do the law of cosines again. I now have 2 out of 3 angles, so I can subtract from 180. So I can simply do 180 minus 67 minus 64.320. And that is 48.680. And that is it for problem number 48. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.